All right, this is the second video when it comes to differentiating trig functions. What I'll do is I'll start with some questions from the homework. I believe we start here, 1I. If you want to pause the video, or you can just go right to the Teams app and find these in there. There's 1M, 1N. There's 1U. Okay, it's a lengthy one. I had to simplify these. There's 2A. There's 3B. All right, this is one where you had to find the equation of the tangent to the curve. Now, those were all from exercise 7.1. All right, again, we're going to be using these same differentiation rules, or the rules for differentiating trig functions, and they are as follows. The derivative of sine u is equal to cosine u times du. The derivative of cosine u is equal to negative sine u times du. The derivative of tangent u is equal to secant squared u times du. The derivative of cosecant u is equal to negative cosecant u times cotangent u times du. Secant u is secant u tangent u du. And cotangent u is its derivative is negative cosecant squared u times du. Remember in the previous video we said all of the trig functions that start with c, so cosine, cosecant, and cotangent, their derivatives are negative. Okay, that's one thing to kind of remember. At least that'll keep straight which ones are positive and which ones are negative. So let's start with a few examples. The first few, it asks you to simplify your answer, and then I'll do a few where you do not have to simplify your answer. Okay, you could do this question using the quotient rule. I would argue that it's quicker to rewrite it as the following and use the chain rule. So I brought the 1 plus tangent x all the way to the top. Its exponent was a positive 1 down here, makes it a negative 1 up there. That 1 would go right here. And when I do the derivative, I can just use the chain rule. So negative 1 times positive 1 would give me negative 1. Rewrite the bracket. 1 plus tangent x. Reduce the exponent by 1. So negative 1 minus 1 gives me a negative 2. Now I multiply by the derivative of what's inside the bracket. Well, we know the derivative of 1 would be 0, so I'm not going to write that. Okay. Now I want to do the derivative of tangent x. So kind of block everything else out and try and figure out what the derivative of tangent x is. That's where I have to use my rule. Okay, so in this case my u value is x. The derivative of u would be 1. The derivative of tangent u we know is secant squared u. So secant squared u is x times the derivative of u times 1. And that's that. And again, all I'm doing is using this rule right here. The derivative of tangent x would be secant squared x times 1. And now I got to clean it up. Okay, so negative 1 times secant squared x times positive 1. That would give me negative secant squared x. This 1 plus tangent x in brackets to the power of negative 2 would just go to the denominator and become a 1 plus tangent x to the power of positive 2. That is my answer. Okay. Another example where I have to simplify. All right. Remember, when the exponent is attached to the trig function, so that 3 is on the cosecant, that's like writing the following. 2 times cosecant 3x squared to the power of 3. Okay, that's how you would write that. And when I do the derivative, now I'm going to use my chain rule. 3 times 2 would give me 6. I'll rewrite the bracket, cosecant 3x squared, reduce the exponent by 1 to the power of 2. Now I got to multiply by the derivative of what's inside the bracket. Okay, well the derivative of cosecant u, in this case my u value would be 3x squared. My du, the derivative of that would be 6x to the first. okay? And the derivative of cosecant u, remember, is negative cosecant u, so 3x squared, cotangent u, and I'll put this argument in brackets, times the derivative of u, times 6x. Okay, if you're wondering where that's coming from, I'm differentiating this right here. I'm just using this rule right here. Derivative of cosecant u is negative cosecant u, cotangent u times du. So all of this, what I just wrote right here, would come after this bracket. All right, to clean that up, I would do the following. 6 times negative 1 times 6x. That would give me negative 36x. This, I'm going to pop that exponent back in here, so it would become cosecant squared, 3x squared. And then I'd have a cosecant 3x squared and a cotangent 3x squared. Now, you might notice that this will combine with this because I'm multiplying. And you didn't have to do this in two separate lines. You could do it in one. Negative 36x. Cosecant squared, since the arguments are the same, okay, since the 3x squared, this is a 3x squared, this is a 3x squared, you can combine those. So cosecant squared, 3x squared, times cosecant to the first 3x squared would give me a cosecant cubed 3x squared. And then the cotangent 3x squared would follow suit. And that is your final answer. Now those are two examples, all right, where you had to simplify your answers. Let's look at a few where you do not have to simplify. All right, so let's say y equals the tangent of 8x to the fourth minus 3x. Instructions tell me to differentiate, and they say do not simplify. Differentiate means find the derivative. Okay, so for this one, I think it's safe to say our u value, okay, and you don't have to do this, I just like to do this. And my du would be 32x cubed minus 3. So my derivative, dy over dx, if we go some Leibniz notation, the derivative of tangent u is secant squared u times du. Now, that's fine. That is the answer. Do not have to simplify. Just one little note. If I did simplify, all I would probably do is put this green binomial in front. You do not multiply that by this. This blue 8x to the fourth minus 3x is the argument on this trig function. Okay? Do not have to simplify, but if you were simplifying, all you would do is put this green binomial in front of this the secant squared. Let's go with another example. So we'll call this 1, 2. Let's say y equals cosecant root x. All right. The derivative of that, y prime. We go Newton notation this time. It starts with a c, so I know it's a negative. The derivative of cosecant root x would be negative cosecant. In this case, my u value is a root x, okay, or an x to the 1/2. The derivative of that would be 1/2 x to the negative 1/2, or 1 over 2 root x, if you will. So the derivative of cosecant u is negative cosecant u, cotangent u, times du. And since it said I didn't have to simplify it, I'll just leave it as is. That's it. That is the derivative. Do a couple more that we don't have to simplify, and we should be good. So number 3, let's do one involving the quotient rule. So it says y equals square root of 1 minus secant x cubed. And on the bottom we'll go cotangent to the 4th times 5x squared. Might want to rewrite this as with an exponent of 1/2 and the following as cotangent 5x squared all to the 4th. Okay, so this is going to require quotient and chain rule. So the derivative of y would be dy over dx, or y prime. When I'm using the quotient rule, I do the derivative of the top. The derivative of the top would be 1/2 times 1 minus secant x cubed to the 1/2 minus 1 negative 1/2 times the derivative of what's inside the brackets. Okay, so the derivative of 1 would be 0. The derivative of negative secant u. All right, well, the derivative of secant u is secant u tangent u times du, so this would be negative secant u, or negative secant x cubed tangent x cubed times 3x squared. Okay, because my u value was x cubed, my du would be 3x squared. Now remember, that right there is the derivative of the numerator. That has to be multiplied by the denominator. Well, the denominator says cotangent to the 4th 5x squared. So from here to here, that is the derivative of the numerator times the denominator minus the numerator. And I'm running out of space here, but I'll just hook it down here. The derivative of the denominator. So the derivative of the denominator, I'm going to look at this piece right here, and I'm going to differentiate it. Chain rule, 4 times, rewrite the bracket, cotangent, and then 5x squared, close the bracket, to the 4 minus 1 would be 3. Don't forget to multiply by the derivative of what's inside the bracket, the derivative of cotangent. All right, starts with a c, so it's going to be negative cosecant squared u, 5x squared, times du. The derivative of u would be 10x. Okay, close that bracket. So my u value in this particular one was 5x squared. The du would be 10x. And again, if you're wondering where that came from, just look back a couple of slides. You should have these in front of you. The derivative of cotangent u was negative cosecant squared u times du. So I had cotangent 5x squared, so its derivative would be negative cosecant squared 5x squared times 10x. And this whole thing, all right, so there's like my f prime from here to here. There's my g at x minus f of x right here times from here to here is g prime x, from that bracket to that. It's all over the bottom squared. Now, if I squared that, cotangent to the 4th 5x squared times cotangent to the 4th 5x squared would give me cotangent to the 8th 5x squared. And you don't have to simplify that. All right? Let's do one last one, and then I think you're probably good to have a go at these on your own. F of x equals the cosine of radical 5x minus 1 plus the tangent of x cubed. F prime x. So a couple things. With the first one, there's no like, since you're adding these two terms together, there's no product rule or anything. It's just simply the derivative of this plus the derivative of this. I would say here your u value is 5x minus 1 to the 1/2. The derivative of that would be a chain rule. 1/2 times 5x minus 1 to the negative 1/2 times 5. The derivative of 5x minus 1 would be 5. Over here, this one's a little less complicated. U is just x cubed. The derivative of u would be 3x squared. Okay. For this one, this piece, the derivative of cosine u, it starts with a c, so we know it's negative sine u, or radical 5x minus 1, times du, plus the derivative of tangent u is secant squared u, so x cubed, times du. And that is the derivative. Doesn't have to be simplified. There's my final answer. All right, your homework is to go to work on exercise 7.3. Okay, so finish up 7.2 and then go to 7.3 on page 319.